Okay, for this experiment what we're doing is a pour plate. It's another way of growing the bacteria, but instead of doing a street plate on top of a prepared agar medium, you'll notice we have empty plates here. We have agar, molten agar in these tubes. So what I'm going to do, and the timing on this is fairly critical. You have to have the agar in a molten form. Flame the loop. Flame our initial inoculum tube. The timing is critical because agar tends to solidify around 45 degrees Celsius. You don't want it hot enough where it's going to kill the organism, but you don't want it to solidify in the tube yet. So I'm going to inoculate in this medium. Now I'm going initially here to flame my loop again. In the tube, I want to mix the bacteria up in the tube. This can often be accomplished by rolling the tube like this. So I mix the bacteria in with the agar. What I'm going to do is dilute this out essentially. So I'm going to use this now as the inoculum. I just inoculated it with E. coli from the original stock culture. Now I'm going to go into this agar. The idea is if you have a really high concentration of bacteria, high amount of it, you're going to slowly be spreading out or diluting it. So now I'm going to go from this first tube into the second tube and inoculate it. Just like you would normally inoculate a broth. Mix that. Flame your loop. You want to mix this tube up. Now, the first tube, we've already used this for our inoculum. What we're going to do, this is a pour plate. So I'm going to now pour this into the Petri dish. Swirl it around a bit. The idea is that the bacteria on a spread plate, you're just spreading it on the top of the agar. What we want to do in a pour plate, theoretically, depending on the organism you're working with, the bacteria is mixed entirely within the agar, so it may be growing within the agar, it may grow on the bottom of the plate, halfway in the middle. Depending on what its oxygen concentration or oxygen requirements are. So the second tube, I need to do the same thing. We already inoculated it. I'm going to go in, a little hot there, and inoculate the third tube. So we're going to end up having 3 different plates. The third plate should have fewer bacteria in it as compared to the first plate. I say the timing of this is critical because if you do it too soon, the agar is too hot and it will kill the bacteria. If you wait too long, it starts to solidify within the tube itself. So second tube, mix it and pour it. That's why it's called a pour plate. Swirl it so it's evenly covering the bottom of the plate. And now we will go with the third tube. We're going to use 2 different bacteria. This is with E. coli. we will use Bacillus subtilis for the other bacteria. We will need to let these solidify before we invert them and put them into the incubator. These are our pore plates. We had 2 different bacteria. On this row we had Bacillus subtilis, and on this row here we had E. coli. These were the pore plates, and so if you remember, this is where we had inoculated the molten agar and then poured that agar into the plate versus doing a streak plate. One of the advantages of a pore plate is that you get growth not only on the surface but also embedded within the media itself. Now, because we did dilutions, you can see that in this first column here, these 2 were the full strength, if you will, and then we inoculated into another tube and then one from that tube. So this is diluted a little bit, not quite as many colonies. You can't, this is more or less a lawn here, which means you can't necessarily pinpoint individual colonies because there's so many there. A little fewer here, and then the third plate is diluted even more so. There are a couple of individual colonies on these plates. You can see one right here. But once again, one advantage of a pore plate is that you do get that growth embedded within the media. There are times when that may be called for versus just streaking on top.